differentiation. And in this slide, we are going to be considering differentiation with respect to new variables. We also discussed about implicit functions and the slope on line of lines for both positive and negative curves. Now, talking about differentiation with different variables, we need to understand the concept. We say that when we are trying to differentiate with respect to new variables, if we have a function of y is equals to f of x, which we have actually discussed before, and we know that y prime, which is called the derivative of y, is the y dx. So the differentiation, which is the y dx or f prime of x, is now taken in terms of d of dx with respect to the function of x. This is the way we differentiate with respect to new variables. Now, sometimes you can just write this as a f prime, direct solution of x. This is the general notation we give to differentiation of new variable. Now, you might be looking at what am I trying to say here. Yeah, this is definition. To understand how it works, we can just quickly look at simple illustration. For example, we have discussed, let's say we are given y is equals to x squared as a simple function, and the examiner now asks us to find the y by dt. Now, if you watch, what we have talked about before is like we are differentiating y with respect to x. But the examiner in this case did not ask y with respect to x, but rather ask y with respect to t. So when we have this, from the standard definition of new variable, you don't need to disturb yourself. Normally, you can only get the y by dx from this given function. But if you want to get the y by dt, you just follow this simple formula. For example, for you to understand very well, I can say, okay, definitely this answer here, if we go by y prime, or we will say the y by dx, is the same thing as writing the y here is the same thing as d. We have x squared by ds. So, which is now going to be multiplied by function of where you are differentiating to. So, my point here is that if we differentiate x squared, everybody knows we are going to have 2x from their algebra differentiation that we've discussed before. So, all you need to do is what? Differentiate the function itself. Then after doing that, you now multiply by the function in which you are going to. Now, if you watch very carefully, my dear student, here, the function we are considering here, in this case, is the y by dt. So we are going to multiply by the function, which is f of x here is x squared, which will now be dx multiplied by over dt. So this will be the answer to the y by dt. So I hope you understand this simple way of getting answer to differentiation to new variables. So students should not take it something difficult to understand, because all what I'm just doing is I am going to differentiate the function normally, then I am now going to express it in terms of the new variables. Another example for clarification, for understanding's sake, let's take another one. We have if y is equals to, let's take 3x squared plus 4x plus 2. Now, examiner asks us to find the y by dt. You don't need to waste time. The y by dt, excuse me, you can see the expression is in y and x, but you are looking for new variable, the y and the t. So all you need to do here is just the y dt, direct solution from what I've explained. Just differentiate what you have in terms of x. The function of x here is 2 times 3 algebraic form 6x plus 4 multiplied by the function is what? Dx over dt. So this is the way we analyze changing to new variable. You don't need to disturb yourself. I will take one more examples, and I think we can go to the next one. Let's take another one for us to understand very well. If we have y is equals to, let me change the alphabet, sine to the cube over t, then the examiner now asks you to find the y by dx. You can see this now. The expression was given in the y by dt. From the definition I have given to you here, you don't need to disturb yourself. So what you need to do here is just, you are looking for the y by dx, but the expression is in the y by dt. So here you just write the y by dx from my formula which you have here is for us to differentiate the function. as you can see, this is our rule, chain rule that we've discussed before. So the inner function is sine t. Remember that. So if it is sine t, when you differentiate, let's say sine t to be equals to u, the logic. When you differentiate that, you have 3u squared, and you have 3 in terms of t. You are not going to write u. Remember that. So it will be 3t squared. When you differentiate sine t, you are going to have cos t. I hope students understand this. So after differentiating, which is what we have been doing here, then you are now going to write the expression in terms of the new variable, where the variable here is t. The one we've been doing before, the variable here is x. That is why we have the x over the new variable, the t. Here, what we have here is t. So it will now be multiplied by the t over, what is here, over the x. So I hope students understand this stuff, because it is going to be very, very much applicable in our solving of our physics as we move further in our solving. Please don't make mistake. Be very, very careful when you are dealing with stuff like this, and make sure you understand it very well. So always keep that in mind. Whenever you have a function with new variable and you are differentiating with the new variable, just differentiate the given function, then multiply it by the function, the old function in terms of x, divided by the function you are going to. You can see I'm going to the y by dt. The old function is in terms of x. I have the x divided by dt. In this case also, I'm going to the y by dt. I will differentiate this. Then I have the function itself is the x divided by the new function I'm going to. So this is the way we relate all this stuff. Please make sure you don't make mistake when you are dealing with all this stuff. So please note that. So always keep that in mind, so that when you have questions on all this stuff, you are not going to fall victim of error. So the next thing I'll talk about, not to waste time, is our implicit function. So that is the next on the slide. So let's quickly go to what we call implicit function. Implicit function. Now about implicit function, we can always keep it in mind that when we talk about implicit function, we are talking about a function that is more than one in a particular word, in a particular expression. Before now, we have been talking about the function of y is equals to f of x. Now, what we mean by y is equals to f of x, we've already discussed this, that for different value of x, we can get the value of what? The value of y. But in terms of implicit, this type of function is called explicit, because whenever we substitute a particular value, we are going to get a new value for y. But when we talk about implicit function, what we are trying to do is that the function we are defining is more than one. So what we're doing there is that when we have a function in terms of more than one variable, let's say x and y, and it's given to be 0, this type of function can be said to be implicit. Why is it implicit in nature? We can talk about some examples. Maybe you are given something like x squared. Let's just take some x squared y plus y squared plus s cube. I'm just trying to form x and y plus 3xy plus 7 is equals to 0. So if you have a function that is given in this time, if you see here, we are having f, the function, normally for explicit function is defined under x. For implicit function, we have more than one variable. So an expression that is noted, or a function that is expressed in more than one variables, are definitely called the implicit function. So what we do when we are actually dealing with implicit function is that we actually try to differentiate x with respect to y. So what we do now is just when you get the value of x, you now substitute it back to the value of y to get what? The value of y. Sometimes answer might be defined, and in some cases answer might not be defined. So it depends on the nature of question. And you can also have it in other example. It can be in terms of sine xy is equals to 0. So you can see if function is given in this, because you're having two different variables, x and y. It can be t and u, it can be any alphabet. In that case, you are considering this type of function to be an implicit function. Then the question is, how do we go about solving implicit question? To understand that very carefully, let us take some good example and teach you very quickly. We are learning basics, and I don't want us to waste time on understanding the concept. Now, about the basics. Now here we have examples here. Let's take the first one, just like what we have here. Or we can take x squared y plus y cubed plus x cubed is equals to 0. The question is, find the y dx. So now in this case, you don't need to be told that this is not an explicit function of y equals to f of x, but rather an implicit function because you're having more than one variable. Now what we do, guys, is just we are going to differentiate x in terms of y. In a layman language, not to waste time, differentiate x. Whenever you differentiate y, you are going to have what? You are going to write or put in brackets the y by dx. That is the logic we employ on that implicit function. So going by that, you can see x squared y are connected by product rule, which we have already discussed. So we can now say y prime here is now equals to, when we differentiate, remember the product rule, we said we differentiate the first one, we take the second one, we differentiate the first one, we take the first one, the second one, blah 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 blah. So using chain rule, because this is x squared y connected by product, we can say here, if we take the first expression, we have we take our x squared, as you can see, then you can see this, we differentiate this one. When we differentiate 1y, we have 1. I hope students still remember this, because I can see that a little bit of confusion. I am trying to differentiate one by one. X squared and y are connected by product rule. From product rule, remember, you take the first one, you differentiate the second one, you take the second one, you differentiate the first one. So that is the logic. So if you want to go by that, maybe we should start by this. For understanding, so I'm taking the first one, so I have y multiplied by, when I differentiate this one, I'm going to have 2x. I'm going to add it to, now when I take the first one is x squared, then when I take this one, when I differentiate y, I am going to have the y by dx. Then I move on, the next one here is plus. When I take this one, I will differentiate y cubed. I'm going to have 3y squared in bracket the y by dx. Then I have a plus. Here I'm going to have a 3x squared, that is differentiating x cubed, is equals to 0. What I'm trying to say, my dear student, is whenever you are dealing with implicit function, you have to understand that whenever you differentiate y, you are going to put the y by dx. And that is why I said we are differentiating directly two variables with respect to y. So that is what I'm doing. So all these are grammar. You may actually not need it. The process and methodology is what is important. Whenever you are taking y, you put the y. You can see here, 3y raised by 3 algebraic form is giving me 3y squared. I hope students to remember this. But because it is y that I am differentiating, I must put in bracket the y by dx. So from here, what we do here is just, we have the y by dx in bracket. You can just bring them out in this form by saying the y by dx. Let me come to this side. Then you are going to open your bracket. What you have here, the first one is x squared. What you have here, plus 3y squared. I hope students are following. And is now equals to, you are bringing these other values. 2x times y is 2xy, and this is a 3x squared. So what you are bringing to the other side is you have a negative 2xy minus 3x squared. So making the y by dx subject of formula, you have the y by dx is equals to a negative 2xy minus 3x squared all over x squared plus 3y squared, which will be the right answer to this. You can also rephrase this one by bringing negative out and putting 2xy plus 3x squared, because it depends on how the examiner actually finalizes the answer. So I believe you've learned all this from your algebra class, and that should be the answer to that question. So that is the first one. We can also take another one for understanding's sake, and let's do that in the next slide. Now, about the second example, still on implicit function, we can look carefully into another simple one. We have, we have x to the fourth power y squared plus sine y squared is equals to 0. The examiner asks you to find y prime. Y prime is equals to. Now, from here, from what we've discussed, these and these are connected by product rule. So what we do is just the same thing. So we differentiate this one, differentiate 4x. You have x raised to the power 4 will give you 4x to the third power. Then you write the first one the way it were, that's y squared. Add it, I'm using my product rule. Take the second one the way it were, you have x to the fourth power. Differentiate y squared, you have that is 2y. Remember, whenever you have differentiating y, you put the y by the x. Remember that. We move on, plus, let's go to this is y. When this is sine y squared, remember the rule, the chain rule we've discussed. So you have sine t. I told you you must learn how to write it out on paper. So when you differentiate, when you have sine t, differentiate sine t, you are going to have cos. I hope students are following. Cos y squared times 2y. When you differentiate y squared, you have 2y, and you have dy by dx is equals to 0. I hope students are getting this. Then you bring out the y by dx outside the bracket. So from here you can say the y by dx. The first one I use the product rule. Here I use the chain rule to differentiate. I hope you are following. Then open the bracket. What you have beside the y by dx, put it alongside it. Here you have x to the fourth power, then 2y. Then here you have plus, you can see plus, I hope students are getting this, cos, I have a cos y squared times 2y is now giving us, when this one moves to the other side, it's going to give us negative 4x cubed y squared. Please, my dot here means multiplication. So finalizing that, you can see without wasting time, and just say the y by the x. When you make it subject of formula, will be what is up here. And if you are so good in mathematics, you can just take out one y from each of these, and you can just cancel out directly without wasting time. So y we cancel y and also take out another y here. So the y by the x from what we have here will be negative 4x cubed y all over, I believe students can see this, this is 2 times this one, that is 2x to the fourth power. You can first of all actually write all these things out, then you now cut. If you are not so good, put the square here, put the y by this side, then put the other one. It doesn't stop anything. Plus cos y, or 2y cos y. That is the best way to write out. It's a cos y times 2y. So if you like, you can also try to factor out 2, because 2 is common to both sides. As in, you have negative 4s cubed y all over, this is what you have here, 2x4 plus 2y cos y. So if you like to factor out, you can factor out to the lowest possible form, and that will be the answer to the question. So I hope you guys understand all these, because all these are very, very important for you to understand, because as we go forward, it is what we are going to use. Please note that. So always have that at the back of that. This is y squared, not y, and the y here cancel y, and the y here, this should be 2 and not 2 cos y. I told you, if you are not so good in cutting directly, you can just write this first, this divided by this, then you cut in your own way. So that is that about that. We move to the next part. Now about the next part, we want to talk about the graph of a function and its slope. That is the next part here on this slide. Graph of a function and its slope. So to analyze that carefully, we are going to use a diagram of x and y plane to classify that and to get what is needed under that. Now a quick one, my dear students, we can say, okay, this is not what I want, but we can just take it the way it were. So from there we can just take this and say, fine, we have an xy plane. To understand the concept very well, let us bring it to diagram as usual, just for us to understand carefully. I think this is better. Very good. So here, from here, we can just say this is an xy plane, x-axis and y-axis. We are trying to analyze the graph of slope of the graph of a function and its slope. Already discussed in early classes that when you talk about a slope of a graph or a function, we represent function by y is equals to f of x. Always keep that in mind, please. This is very, very important. Now, if we have a curve, let's just take a curve and try to look out for the slope of the line. From what you've studied in your early classes, I just want to take a curve. Now, and on top of this curve, we have discussed that if we take a point, let me use a black marker. If we take a point here, which is our definition of differentiation, we take a point from here and we try to get the value of x. We are going to get a particular value for y. This is too high, but I'll just manage that. But if we also move up and we move from x and go to another point on the x graph, let's call that point, my way of doing things, remember x plus dx, which was the beginning of the concept. We are going to get another value, diagram not drawn to scale, for y, which is somewhere around here. So now, the first value here, we say the value of y, then an elemental change to y plus dy. So if we carefully analyze this, we can call the first point here the point P. Let's change this to blue. And we call the second point here, diagram not drawn to scale, point Q. Now, what we are trying to say from this point is that if we bring a tangent line, which is very important for us to understand, we try to bring a tangent line from P. Is, like I said, diagram not drawn to scale. Okay, let's do something different to understand carefully. Okay, let me extend my line here. I want it to be a little bit good. So let's say we are trying to draw a tangent line from point P. You know, tangent is the line that touches the line. It's going to touch it externally. It's not straight. I want it to be very, very straight. But as you can see, we are trying to bring in something that is so unique. But here, I'm not forming what I want to form because the line of tangent I'm trying to draw here is not straight. Maybe I should use my hand there if this is not giving me what I want. Okay, fine. Let's just take an arbitrary line. I think that will be better for me to use my hand because my hand is better than what I'm seeing here. So let me use my hand to draw. So maybe we have a tangential line like this that's obtained an angle of theta here. So we can say that the theta here of this, I'm trying to draw a tangent on P. The tangent line is just a line that touches the curve externally. So now here, it's obtaining an angle of theta to the x-axis. So we can say from what we have learned, like we say the slope of this curve, slope of the line, is given by the change in y, which is what we call rise, over change in x, which we call the run. So you can see it is changing from x to the x and y to the y. And if we go by this, we are going to have what we call tan theta. So now in this case, if we carefully analyze what we have here, we can see that tan theta is the same thing as the slope of this line on the point of P. We always keep that in mind, that tan theta is the slope of the function, and sometimes slope is given as an alphabet or symbolized by m. So students should keep it in mind that the slope of a line is the same thing as what we call tan of the angle, because remember, this line is telling us how high this thing is running, and how high it is and how wide it is. So we are talking about the rate of change of the y to the x-axis, so which is what we call the slope of a line. Now basically we can also look at it from another way. Now if we look at this angle here, this P and Q, also we can also bring out a kind of a straight line. Let me just try to join line P and Q together, I guess with a blue line for understanding sake. So if we have something like this, you can see, dear student, when you're trying to make a line here, then the angle here can alternate here. What I'm trying to show here is not drawn to scale, but if you can see, you're having something like a right angle. The change here is what we have here. We have a dx, or x plus dx, and the one here we have a dy. So which is also the same thing by saying the slope of a line is nothing but the tan of the angle it makes, or the change in what we call dy by dx. So the only thing I just want you to keep in mind here is for you to always keep it in mind that the slope of a line is also the same thing by finding the derivative of the line, or by looking directly to the angle, the tan of the angle that is obtained by that particular line. So that is just that. Then again, we can also consider the slope of increasing and decreasing function. A very quick one because of time. Just to finish this. Now, talking about the slope of increasing and decreasing function, we have already studied that tan theta is equals to the y by dx, which is the same thing as the slope of a line. Now, students should always be careful that you can also have the slope of a line in two categories. It can be a positive slope and it can be a negative slope. Maybe I should manage this side for a quick explanation of the two. Now, maybe we have a curve in this way. I think I love using red, and we have a curve in which the line of the curve is increasing like this. Now we can say this is y-axis, everybody knows, and this is x-axis. I need to up my pace because of time. Now we try to draw a tangent line so as to calculate the slope. Remember, let me just take a point. I think this should be very, very straightforward. Just take a point from here and bring out a tangent line as usual to get the slope. We can say the acute angle in which the tangent is making. The acute angle in which the tangent line is making. We are talking about acute angle. You know, acute angle is, we are taking the angle of the tangent. This is point P, for example. Slope of the line here is an increasing slope. Now, because it's an increasing function, this is a function we call increasing function. The graph is increasing. For every value of x, the value of y is also increasing. That is why we call it increasing function. So in this case, we say tan theta, which is the acute angle that is being made by the tangent, is always going to be the y divided by the x, and it will always be positive. So the only thing I want to talk about here is that when the graph is increasing graph, slope will be positive. And if it is otherwise, carefully understand this. I have 2 minutes more. Now, if we have the situation whereby the graph we are considering is not an increasing graph, so maybe we have a decreasing graph in this form. Maybe we have something that is going down like this. Diagram not drawn to scale, y-axis, x-axis. Then we try to draw the tangent from this point. Let's just take a point there. My dear students, I hope you are getting all this. Just a direct way, but because of understanding sake, that is why we are trying to do that. So now, when we draw the tangent line here, it's going to form something like an obtuse angle, and we know that okay, fine. Okay, we can just extend the slope and the tangent line upward like that. The angle it's making here is theta. So in this case, this is a decreasing function, because for every increase in x, y is decreasing. So it's a decreasing graph or a decreasing function. So in this case, you can say The slope of this line, which we call tan theta, is an obtuse angle, which is the same thing as the y by the x, and is always going to be negative. So the point I want you to have in mind is that for an increasing graph, slope is positive, and for a decreasing graph, slope will always be negative. So guys, this is where we are going to stop on this slide. In the next class, we discuss about the remaining part of our differentiation, which is talking about maximum and minima and some other important things.